We want to write the pH scale in terms of something measurable because even a small cup can hold a nearly uncountable number of molecules. Avogadro's enormous number, 6 times 10 to the 23, was used to create a quantity called a mole. Moles relate the number of molecules in a substance to its mass measured on a scale. For example, 18 grams of water is 6 times 10 to the 23 molecules, or 1 mole. A mole of hydrogen atoms is just 1 gram, only 17 grams for hydroxide molecules, but sugar needs 342 grams for 1 mole. Writing the pH scale in terms of moles makes the numbers easier to read and to prepare solutions that change the pH level and the color of cabbage. Recall that acids have more hydrogen ions H+ than hydroxide ions OH-, and vice versa for alkalis. Let's start with 1 mole of H+ and build the pH scale from 0 to 14. A strong acid of pH 0 has 14 trillion times more hydrogen ions H+ than hydroxide ions OH-. In other words, a pH of 0 has 1 mole of H+ and 10 to the minus 14 moles of OH-. Put those two data points on the top and bottom of the graph at pH 0. For every step the pH level increases to the right, there are 10 times less H+ and 10 times more OH-. For example, a pH equal to 1 has H+ equals 10 to the minus 1 moles, and OH- is equal to 10 to the minus 13 moles. Continue reducing the H+ by 10 times and increasing the OH- by 10 times. Notice it is easy using scientific notation since the exponent only changes by 1 each time. Also notice that at pH level 7, there's an equal amount of H+ and OH-. Both have 10 to the minus 7 moles. So the pH is neutral, not an acid or an alkali. For alkalis, the pH level is 8 and above. There are more moles of OH- than H+. For a very strong alkali with pH level 14, there's 1 mole of OH- and 10 to the minus 14 moles of H+. In other words, 14 trillion times more hydroxide ions than hydrogen ions. Recall that pH stands for potential of hydrogen. The number of pH scale are really just the negative exponent of the number of moles of hydrogen ions H+. The entire pH scale can be written as a logarithmic function, pH equals minus log H+, where H+ in brackets is the moles of hydrogen ions. Notice that in scientific notation, 1 is just equal to 10 to the power of 0. You can try it yourself with a calculator that has a log and an x to the power of y button. For example, an acid with a pH level of 4 has H+ equal to 10 to the minus 4 moles. So the negative log is just 4. An alkali with pH of 9 has 10 to the minus 9 moles of H+. Now that the pH scale is related to something measurable like mass, we can see how substances like baking soda or the acetic acid in vinegar change the amount of hydrogen and hydroxide ions to alter the pH level and change the color of our beloved cabbage. Slam through the quiz and we can prepare some useful color-changing solutions.